All right. Hi, everybody. This is the Kubernetes Workgroup Device Management call for May 13th. We have a pretty packed agenda, so we're just going to get started. First thing on the agenda is planning. And I think if I go through this whole list, we will do nothing else. And I'm not sure that's the best use of our time. There's a lot of other items here, but I do want to spend a little bit of time on it. So I have two lists here. The first list is linked here. This is sort of our aspirational list of things we want to get done in ideally along this timeline. So I added this morning, I started to add a column for who's kind of leading that effort. But this is an awful lot of stuff. Some of these remain in alpha, but that doesn't mean no engineering work. And then others are new alphas. From my point of view, let me put this window here so I can see if anybody raises their hand. From my point of view, I think getting this to GA is the top priority. And I know we have a number of people working on different parts of that. And then to me, the second highest priority is getting this to alpha. And the reason is that, at least for us at Google, trying to transition to DRA away from device plugin for the devices that we manage with device plugin right now isn't really viable until we have a way to do it seamlessly for users. And what this does is allow existing manifests that use extended resources to continue to function as before. It allows people to continue to use extended resources if they don't need the functionality of DRA, but it allows the administrator to deploy only DRA drivers. So we don't end up splitting the cluster into two groups. We end up with, any node running the DRA driver can service any pod using either extended resources or resource claim API. So I had hoped we'd get this last time, but we introduced it too late. So we're looking at doing an alpha in this release. Beyond that, I have a ranking of my own. I'm sure everybody else does too. Anyway, I wanted to open the floor. The other list, before I open the floor, the other list is things that aren't there, but we've talked about or are in progress in other ways. I'll call out this first one in particular. We're hoping, I don't know if Marlo wanted to talk about it more, but we're hoping to submit a request for a repo to start to build a driver for this. It'll be a little crude at first because we don't have consumable capacity, but when we have consumable capacity, I think we can make something pretty interesting there. So with that, I want to open the floor to further others' comments, and I'm happy to go through the list and identify what different things are if people want to know, but I think that would, like I said, take the whole time, and there's like tons of things on the agenda.
One thing to note on the CPU DRA is that we are aiming to have it easy to do topology alignment with the cores, and then play with Kevin's GPU plugin to make sure we can get that without having to do weird shenanigans and cross driver communication.
Exactly. So what the whole goal of that is right now, not so much about allocation of CPU, although that's sort of necessary. It's about the alignment at a workload level, not a node level. So it's like, I want to run a workload and I want to align certain devices with one another. And so that's going to be the primary goal of that initially. I think Patrick's hand was first.
Yeah, I want to put the whole plan a little bit into perspective. So at KubeCon at last KubeCon, we were a bit more aggressive and were planning to promote several things faster than what you showed now.
Yes.
The rationale simply is that doing too many, well, twofold. Doing too many things at once puts the GA promotion at risk. We found in the last cycle that key people are basically pretty much busy just keeping up with everything that's going on, and it will not be different for 134. The other is that Kubernetes project has decided to raise the bar for beta features. So the CAP was merged today. It basically says, and I think there was also an announcement email from David Eads, the new requirement for beta is pretty much it has to be GA quality. And I'm not sure whether we are really there with all the things that we just introduced as alpha. And the third perhaps is we don't really have that much user feedback on some of these things. So there's the barking. Hey,
I told you.
he liked what I said, right?
That's right.
Or completely disagreed. I can't tell. So that's it. That's pretty much it. And even for GA promotion, I'm starting to get worried that we are still making quite a few changes for, say, new metrics, observability enhancements, performance in some cases. So we are not exactly promoting what was beta to GA. There will be some changes. I hope it'll be acceptable, but we have to be aware that we are, well,
yeah, it's an aggressive.
even with GA promotion, we are aggressive.
Yes.
Yeah. That's all.
Yep. Thank you, Patrick. Yeah, Ale.
Sorry, my thoughts were for the previous topic. I would be interested in the CPU driver. We have done some kind of alignment, and we have needs for it for the stack that we run. So I'm curious if there are any discussions that I can catch up to. I thought the agenda reflected a link, but it's not there.
Marlo, you have a document, just like a one pager. Marlo has a one pager with some requirements and ideas. If you can link that there, and then maybe we should, we can create a place on Slack where we can coordinate or have a meeting or something.
Sure. Thanks.
Marlo, Marlo is having connectivity problems, but I think we'll take care of that. Sergey?
Yeah, same topic as Patrick just said. It will be great to have some graduation criteria updated on a CAP, so on structured parameters, so we know what the GA means. And as you mentioned that on GKE we'll have troubles upgrading customers seamlessly, but maybe we can have some other way of production validation of DRA APIs. Like I think the message needs to be like in 134. If it's not a GA, it should be close enough to GA so people can start adopting it and trying it out.
Yeah, and so we will have some production usage because I think I saw Kevin's here. The compute domain pieces, which are not, there's no transition there, right? That's a new new plugin, and so we will have some production validation with that. But yeah, I hear you, Sergey. Like, it's definitely. I do want to push hard to see if we can GA it because I want to avoid, it's not enabled by default because of the APIs, and I think we've got our API shape correct now. But I understand, we got to make sure that the punch list is there and all the qualities there.
I'd like to add that GA doesn't necessarily has to mean that it's readily and exactly usable in GKE. That is a downstream usage to some extent. It's of course an important one, but GA makes it usable also for others in other scenarios where they don't care for the extended resource requests, for example. And I think that is, to me, good enough for GA. The quality question is the key point.
Yes, there is one point actually in that change to the CAP that we just merged, a change to the process that we just merged. So one of the key points was that any feature that has never been default on needs to be turn offable, for lack of a better word, in its first release. So we actually will have a disableable GA of DRA because it's never been default on before. So it's almost sort of like halfway between GA and beta because of the default off APIs. It will still be disableable, whereas normally when we go GA, we lock things on.
Is that?
Kevin?
It's been like that for a few releases, though, right? That's not brand new. I know we had that for CDI support in the CRI, for example.
It may be that, well, the default off APIs has been that way for quite some time, but it may be that was the policy, but it wasn't written down anywhere. So now it's written down.
Got it.
Yeah, I was just gonna say that it sounds like for 1.34, should we go with a beta on rather than stable?
We can't.
The problem is the API groups. It's not just the feature gates. There's API groups, and those aren't allowed to be on by default if they're beta.
That's another Kubernetes policy, another CAP.
The reason is that if you turn a beta group on by default, then people start using it. And then when you get rid of the beta and it goes to V1, they have to change all their manifests. So it creates a migration nightmare to turn beta. People start using it without really being, it's I think, yeah, we've been through a lot of pain. I think Red Hat and Google and others have been through a lot of pain with our customers have been through a lot of pain because of that.
That makes sense.
I see that there's a hand who is the outline now.
Yes, for the resource claim status, do I need then to change to disable it by default? Because now it's enabled by default.
No, it's fine. It's because it's part of the API that wouldn't be there anyway.
Okay.
It doesn't. Well, I assume it just doesn't do anything if the base CAP isn't enabled. So presumably,
we may have resource claim status might be on by default in beta, and that's fine because I don't think it does anything at the control plane. Some of the others, like namespace controlled admin access, that can become beta on by default in 1.34, assuming that structured parameters goes to GA.
Yeah, I guess maybe your question, Lionel, was should it be off because once the base CAP goes GA, all the other betas become on by default, and that's okay because they're not new APIs. They may be new fields in an existing API, the V1 of the resource APIs, but they are not new API endpoints. That's the thing that can't be on by default.
Yeah.
Okay.
It can't be on by default if the API group that it depends on isn't on by default. But I think that particular criteria is not relevant for resource claim status because you don't have any code that does an informer on resource claims, I think. So you're fine with on by default, even in 1.33 if that was already the state.
Okay, so what I'd like to ask, since we've taken quite a bit of time on this, is folks look through this list. If you want to take the lead on something and there's nobody there, put your name down. I mean, I know there are people who are already the leads on these, and I didn't finish putting the ones I know about in. So go ahead and put your name there if you're already taking that role. But from a review bandwidth point of view, from our API reviewers and things, like the earlier the better. And so that's, I guess, and that the priority will be on getting us to GA. Okay, if there's no other comments on that, let's move on to the next item. How do I? Okay, so as is my item 2. So what I wanted to do is just ask folks to give some thought to if there's anything missing for this migration process. So we talked about we want a seamless migration, and that doesn't mean, well, we want cluster administrators to be able to seamlessly migrate from a device plugin based implementation to a DRA based implementation of the same set of devices. I think one thing we're missing is, and maybe we will always be missing, is I don't think we have a way to do that in flight. So in other words, you would need to drain the node. You couldn't just run the DRA daemon set instead of the device plugin daemon set and expect the files on the node to match, right, the expectations. So that will probably be, unless somebody has a better idea, my expectation is that we would drain and rebuild the nodes with the device plugin rather than that.
If you didn't drain, I think it would still work. You just might oversubscribe the devices temporarily, because the device plugin is stateless. There's no call out to it when the devices get freed. That's all internal to the kubelet. But they would be.
But the DRA driver would
have
to know how to take over the allocated.
Yeah, exactly. That's what I was going to say. That's what I meant by be oversubscribed. If they actually got allocated by the DRA driver before they got released by the kubelet plugin one. Yeah. So it's problematic. I think the recommendation would be to drain. Yeah.
But beyond that, yeah, like we don't need to design it here, but if there's any thoughts folks have beyond the extended resource handling, and we'll need to write a migration guide for our administrators on how to do that. So that's all I have on that.
Kevin, can you help me understand how it will lead to oversubscription? Sorry.
You mean if you didn't drain the node?
Yep.
Yeah, so the scenario would be that you have a pod that you start with the standard device plugin. It gets handed a GPU. You then tear down the device plugin. You tear down and you bring the DRA driver onto the node. That container that got handed the GPU by the device plugin is still running. It's got access to that GPU. And then another pod comes along, asks for a GPU. The DRA driver gladly hands that out because the scheduler doesn't see it as unavailable from the perspective of the DRA driver. And now that new pod has access to the same GPU that the original one did. Now there wouldn't be an error in terms of cleaning up that existing pod and then eventually cleaning up the second pod, but there'd be a time when they both had access to the same underlying GPU potentially.
But if the DRA driver can also access list and watch of the device plugin, then they both could be in sync. So list and watch is a public interface of the device plugin, and that tells you what's running on the host, right? So if some other entity.
That's not what the list and watch does. The list and watch is what's advertised by the device plugin to say what is able to be allocated.
Correct.
But the kubelet does all the allocation. Kubelet maintains that state. It never sends any of that. Once the GPU or whatever device has been allocated by the kubelet, it never talks to the plugin again about that device. There's no deallocate call as such to the device plugin.
So you're saying that the device plugin doesn't actually track the allocations, the kubelet does.
Device plugin doesn't track the allocations, the kubelet does. And independent of that, with this extended resource update that or the API that we're talking about adding that allows the DRA driver to service extended resource requests. It's not doing that by implementing the device plugin API. It only implements its normal DRA style API, but there's changes in the scheduler that know how to on the fly transform the extended resource request into a DRA style request and then have the DRA driver service it. It's not like that driver is now aware of both interfaces. It's only implementing DRA and the changes happen at the scheduler.
Because in order to maintain the consistency of allocations in the scheduler, we need to track the state of those allocations in the scheduler, even though they're made through the extended resource API. So rather than tracking them in the kubelet, they're tracked in the scheduler. And so you can't just transition. The kubelet would somehow have to push its state into the control plane to make sure all the accounting is correct. And I think that's pretty challenging and unnecessarily challenging when you can drain the nodes.
That makes sense. That thanks both of you. My motivation was mainly that since there is no real requirement from the GPU driver on this, it just this whole node drain requirement is coming solely from the Kubernetes side. So the workload could have kept running, but we have to interrupt because of the our limitation.
Yeah, kind of sucks.
That's right. And it's because the scheduler originally never tracked the actual GPUs that were allocated. It just tracks a count, and it leaves all of that state maintenance for what GPUs were actually handed out to the kubelet. And in fact, it doesn't even delegate that to the plugin. It's all internal to the kubelet. And so we'd have to do some fancy tricks to somehow have that be pushed out to the control plane, like John said. I'm not sure we would want to do that just to support this.
Yep, sounds good. Thanks.
Okay, awesome. Thank you. Update on Q.
Yeah, I just wanted to call out that there is a new proposal in the Q repo to integrate with DRA, and the PR looks pretty interesting. So I just wanted to bring that to everybody here. It looks like it's gotten quite a bit of feedback so far, but if anybody else is interested in taking a look, please do so.
Yeah, Ale from NVIDIA, he's the one that wrote that, and I think he's here in the call, actually. So if we did want to go into the details of that later, I think we could.
Okay, well, maybe we can, if we get through the whole agenda, we can either go through that or go through the details of the enhancements, whatever people want to do. JP?
Yeah, hi. Can you hear me?
Yes.
Awesome. Yeah, so this is just an update for KEP 4680 for pod health status, specifically for DRA. I have an initial design implementation or an implementation design overview, and in that there's linked an initial PR that has unit testing. Just kind of calling this out if people are aware of it and would like to contribute and comment, critique it.
Yeah, actually, I would like to get a little discussion on some things here. So this is a KEP we've had here for some time that it's already implemented for a device plugin, but the idea would be for DRA devices. And what we do is reflect the the device status into each pod that's using the device. So even if there's multiple devices sharing multiple pods or sharing the same device, they both see it in their pod status. I think that's a good thing because it gives the user one place to go. But I did add at the maintainer summit, we had a session and we asked the question, all right, we've spent a year working on stuff. What are we still missing? And one thing that came up was, did I not put it in here? That's ridiculous if I didn't put it in here. Okay, this is the one we were just talking about, and then this one. So these are related, but not necessarily mutually exclusive. And so that's what I wanted to discuss here. So the idea here is folks were asking for, they're like, hey, we're all building our own controllers, sort of like node problem detector, right? Like that'll find a problem and maybe, but even allow you to mitigate, right? So like, oh, I need to reset the GPU. It's crashed or whatever. And everybody's like, we're building our own tooling for this, but it's kind of silly that we all build exactly the same tooling with different, in slightly different ways. Is there some commonality we can bring together? So what this proposal is this is just one idea, would be like, can we at least put the status, let drivers store the status of a device in the resource slice? Today, if a device isn't healthy in some way, we withdraw it from the list of available devices. This would say instead, or maybe in addition, because the scheduler right now relies on that withdrawal, but put a status in there with some, they're going to be vendor specific, but some error codes that a controller could be watching that resource slice. And when it sees something in the status that it knows how to mitigate, it goes and just does it, right? And makes the device healthy again, or it raises an alert in some observability platform. So that's devices separate from where they're used in pods. JP, the cap he's talking about is the actual usage within the pod, which could include additional types of failures. For example, if the pod requires a configuration applied to that, right? That I'm not sure where that, if there's a failure in that configuration, does that belong in resource slice status? Probably not. Resource claim status? Maybe, because that's the common, even multiple pods, right? All use the same resource claim. What is it? So there's a sort of like a question here about where these different statuses should live. And I see we have hands. So I don't know who is first.
It was Patrick. Go ahead.
Yeah, well, there is some overlap with the device taints. So one of the ideas behind device taints is that you don't need to remove a broken or unhealthy device from the resource slice. You just publish a device taint in the spec. I still see potential for doing something similar in the status. We could standardize, I guess, some additional fields, but I would like to call out that we can kind of do the same also with standardizing attributes. So it doesn't necessarily need to be a status unless we envision other components besides the driver itself to set that status. So it depends a bit on what goes into this cap, whether it's augmenting device taints or just is redundant. It depends on details a bit.
I think you have a good point though, that the rather than the withdrawal or even having the scheduler look at status, we could have something that looks at status and taints the node, or the driver, if it's writing the status, could taint the node or taint the device at the same time, and only have one mechanism by which we control the schedule, no schedule, execute, no execute behavior, instead of having the scheduler have to check the status too, which like it doesn't right now. So that would, that's a good point. Laura?
Yeah, you kind of touched on this already, but just want to poke on it a little bit more about the idea of the device health tracking information being in both resource slice and in pod status, and also possibly them like having some of the same information, but then maybe also having some different information, like just, I guess, as a direction, like how we feel about that, and like if that's really like a viable way that we want to go forward, that like both of these device health tracking are in these two different places. It kind of just overlaps with some of the stuff I'm trying to like do trade-offs related to like who monitors and who's responsible for like, cleaning up after this, that, or the other thing for the like reliability side. So that's why like as a pattern, I'm wondering like as a pattern in the broader scope of DRA of having like multiple responsibility for the same type of thing split across multiple APIs, if that how we feel about that. That's my question.
Yeah, exactly. I think we need to sort like JP and I talked a little bit about like, right, you could reflect this. It's sort of like a tree, right? Like you have the slices at the root of the tree, and then you've got claims, and then you've got pods. And so, you know, you want from a user point of view to be able to see it at the leaf, at the pod. Also, potentially there's additional errors that can be layered in at each layer, at each set of, you know, each level of the tree. So I think it might be reasonable to track them over there, but I guess maybe rather than trying to figure it all out here, what I would ask is that somebody take the initiative to start to like, we don't need to combine the caps, but maybe in this cap, because really it says resource slice status, but there's also potentially resource claim status. Like maybe we should start at least a doc where we start to discuss that. I don't want to disrupt necessarily this because I think this is fairly well understood because it's already done for device plugin and it's the leaf end of that. But if JP or Laura or somebody else wants to kind of take the initiative to start working on coordinating a design for this error tracking across the spectrum, that'd be awesome. I see Sergey has a hand.
Yeah, I wanted to echo what you said about two different views on an error, and there is a different view. Like in the device plugin, it was easier. There is a single view on a device's health. It's from Node, and Node is responsible for promoting those devices and marking them unhealthy. Now we have Kubelet needs to know a little bit about device health, and scheduler needs to know about device health. So we have this problem of potentially inconsistent device health reporting by DRA. Like if DRA will tell Kubelet one thing and scheduler another thing, then we'll have some inconsistencies that we'll need to resolve somehow. But my question is, writing it down sounds very good. Like we need to write it down and understand what's happening. And my question is, for GA of structured parameters and for transition from device plugin, do we recommend to taint resources when they're unhealthy, or do we recommend to remove them when they're unhealthy? Or will GA will be removing and tainting will be like after some time after GA?
I think it's going to have to be that because taints, like I mean, I'd love to get taints to beta. I don't know that that's really going to happen in this time frame. Right. So just realistically, like we went through the list, like the previous list that we showed at KubeCon, like had a whole bunch of betas here. And it's like, it's just realistically, I don't think we have the bandwidth to make all of that happen. So I don't see taints getting ready in time. And so I would rather, I think withdrawal of the device is still the recommendation in the GA timeframe. Once maybe in the 135 timeframe, it'll be possible to use taints instead.
So people start writing some maintenance handlers like to check whether the device was removed or something like that. Do we need to go through migration then if we'll start tainting instead of removing devices? How will this notification look like? Like we have a GA feature that removing devices. Now we having beta feature going to GA that suggesting to taint devices instead. And it's a change of behavior. Do we go through transition period, like migrating customers somehow?
I mean, either approach is still valid. later. So I wouldn't so much call it a migration as that there's additional options that become available later.
My expectation also would be that downstream components need to be prepared for both, because it is the DRA driver author that decides which of the two methods to use. Right now, they only have one option. They can remove the device, but they might decide to just keep doing that, even if device taints becomes beta or GA. We don't know. I don't think we can't force them either way to do one thing or the other.
Oh yeah, I like this way to view this. Like, so we're saying that people need to understand new API which is taint, and they need to react on that taint correspondingly.
They can start adding that code. Right now, it would access an alpha field, but I think it could even be consumed. If you want, you can have a feature gate in your downstream component. But what we've done in other places is that we just, if a field is set, it means it was enabled in the API server at some point. Otherwise, it wouldn't be there, and we react to it appropriately. So
yeah, so almost
might just always implement taints if they want to, if they are not worried about implementing something for an alpha feature that could change.
So are you saying that removing the slices now is what's recommended for structured parameters GA, and then in the future, taints and tolerations can be used for devices, and that is neither recommended or unrecommended?
Well, it probably would shift to the recommendation once that's GA, that be the way, because it's especially if it kind of depends what comes out of this error discussion, right? If the error discussion is, hey, let's leave the things in the slice, let's mark them with an error in the status, and we don't want to withdraw them because then you wouldn't have a reference back from the status, and we don't want to duplicate all that data. But we don't want the scheduler to have to look at the status, so then taints become the right way to withdraw them from the scheduling operation. So ultimately, from the maintenance handler's perspective, Sergey, I mean, I think that you probably have to be prepared to deal with either one. Like if you see somehow like that there's an unhealthy set of devices, you expect this node to have 8 GPUs and only 7 are showing up, or you expect it to have 8 and there's 8, but one is tainted with, one is showing an error in the status. Like, I think that I have to understand better what your goal of the maintenance handler is, because like, if it's rebuild the node, like, I mean, I think you can detect that varying ways. I think,
yeah, I think I was first.
Dominic?
I wonder, because taints will be implemented on the scheduler side, so typically no one needs to worry about handling them. So what is the case when someone needs to be prepared for taints or for device removal?
Like, so your point is that a maintenance handler, which is looking at the node, wouldn't necessarily want to calculate whether any of those devices are tainted.
Yeah. I mean, I can at least speak from the maintenance handler side of it, is that it has no consideration about the taints. It just deals with incoming maintenance from like GC dependencies, and it doesn't actually deal with any taints because that's all on the scheduling side.
Right.
So there's no maintenance related components that rely on tainting. You can maybe consider the maintenance controller, but it wouldn't react to those taints. It just reacts to maintenance specific taints. So we have no taint specific reactions from like a downstream maintenance side.
So if the taints are used to control scheduling, it would seem to me that the status would be the more appropriate place for the maintenance handler to be like, oh, there's something wrong with these devices, I need to do something.
Sure, right? Like if you wanted it to react to the status, it'd be more appropriate to attach a status to the node and have either the maintenance handler or the controller react to that. Taints, I don't think is a good idea to react to from like these maintenance construct. Yeah, exactly.
That makes sense. Yeah. Okay, so there's a lot to discuss. Rishi, go ahead. Rishi.
Oh, I was commenting on the fact that I don't think the maintenance components rely on any.
Okay, sorry. Yeah, all right. The main point is, right, there's a ton of stuff to figure out here, but I don't want to hold, well, personally, I don't want to hold GA for figuring this out, right? Like this is additional functionality as far as I'm concerned. So like, let's move to the next item. We're running out of time, but if I can get, anybody wants to either put their name down directly or in a comment or reach out to me afterward or whatever you want to do. There's definitely a nest of discussion here that has to happen around the error handling. Okay. Monique or Ruhi?
Hey, can you hear me?
Yes, we can.
Oh, nice. Yeah, this is just a call out that we have added a new KEP for evaluating a cell expression across the devices. This is basically helpful in ring topology where we want allocations to be device allocations to be in a contiguous manner, and also support slicing in a 2D torus kind of device setup where we could have different slicing like 1x4, 2x4, 4x4, something like that. We want folks here to review it. I think Patrick and John already reviewed it and suggested some changes. So I just want to call out that other vendors feel free to please review this and any other use cases which we need to consider about this thing.
Yeah, and I would say, and I think we've probably discussed this on some of the Slack channel and stuff, but like the slicing thing is something new I hadn't heard. Like as far as if you have valid topological sets that are enumerable, like that aren't like, you know, in factorial numbers or something, then you should look at the partitionable one. Even for multi-node type of things, you can look at what Morton's done around TPU subslicing for multi-node things. I mean, we still have issues there with combinatorics, right? Like, but we're seeing what we can do about that. The advantage there, I think we still need this cap like you're talking about, but the advantage of doing things in the partitionable is that it's hidden from the user. They don't have to deal with it. So that's just, whereas this, the user has to deal with defining those constraints, or you have to create a resource claim template for them that has those constraints defined. But yeah, so this is a good feature. It's on the feature list. So whoever's leading this effort, like when I see leading this effort, I mean, when we meet in 2 weeks, it's going to be, hey, what's the status of this cap? How's it coming? Who's going to be kind of running the show there? Please put your name in that slide, so we get your GitHub handle in the slide.
Sounds good.
We'll sign up for it. We'll put the name down. Question for you: this reference for TPU slicing. Can you post a link that we can review?
Yeah, I think it's Morton. Can you? It's in the cap there, the partitionable devices cap. There's a section, but there's also a document. I don't know if is there a second public document yet?
There's also your talk from KubeCon.
Yes.
Last November.
There's the talk.
I can post links in the chat.
Thank you.
Post links in the agenda, Morton. So it's permanent. Thank you.
Thank you.
So for the slideshow, can you grant us access so we can add our names to that?
You should have everybody. Oh, okay. I can just make this. If you're there, if you're on the mailing list, you have edit access now. And if you're in Kubernetes dev, you have commenter access. So. All right, where were we? LA, scale testing.
Hey, I just wanted to give an update. So the last 6 scalability meeting, I had some discussion around how to go forward with the scale testing for GA. And I think what came out of that is, according to 6Scale, this will definitely be something we cannot go GA without any kind of scale test. So I've started, digging into what a scale test look like. And they recommended that the usual workflow is that a test is introduced with a 100 node cluster first, and then once it is stable enough, it gives us enough reliability, then we can promote that to GA. And the recommended starting point was that batch test that is currently being run on a 100 node cluster. That could be a place where you can just insert resource claim templates and start to get some baseline DRA readings from that. So, in order to test this more, I've started a POC kind of branch, which first installs the example DRA driver, which by default comes up with 8 mock GPUs on a node, and then it runs a job with, requesting resource claims, and then it measures the job latency, pod latency, and then some scheduling metrics. Scheduling metrics for each of the plugin that gets invoked in the scheduler. So that's what I have now in that branch. Next, I will be discussing more on that issue, what kind of workload we want to come up with, and what are the measurements that we should have for the scale test, in addition to what is already available, and that will set us up for the 100 node test.
Awesome. One question is that question of workload. So do we have, I know Morten raised the issue at one point of like the sort of scalability envelope. So what are the different dimensions on which we can test scalability? What are the different, like there's number of nodes is like size of the cluster, but if you're, it could be different if you have, one pod asking for 8 GPUs on each node, or you have, partitionable nodes with taking those 8 GPUs and splitting them into 56 GPUs, and then have mixed pods getting different numbers, right? Like we can see really different performance from our allocator and things like that. Like we probably need to define somewhere a set of scenarios that a set of typical workloads, or even workloads that stress it in one direction or another. Whether we want to block on one that's weird and kind of an edge case is a different question, but like we at least should know the boundaries of what we're testing.
Yeah, that's a very valid question, and I think there could be multiple different dimensions. The focus that, at least with this work, is that we get it ready for structured parameters GA, and leave it open to configure other kind of scaling dimensions. Okay. So the scaling dimensions could be along 2 different buckets. One along the configuration of devices, so what kind of resource slices we advertise, and second along what kind of workloads we have that requests those via claim, right? Mm-hmm. The reason why I'm categorizing this into 2 buckets like that is the workload type is easy because the perf and scale stack we have with Cluster Loader 2 can allow you to create any arbitrary job deployment, however you want to scale up that cluster. So that is, I think that will be fairly easy. The resource slide side of it would be a little bit, that needs a little bit more brainstorming, because currently the POC that I did installs example DRA driver. And if we were to build this scaling test on the example DRA driver, then whatever feature, apart from structured parameters that we need scale test for, will first have to be supported in the DRA driver. And then that support has to be brought into the scaling test. So that is the exact reason why I have this topic here for discussion. Do folks have thoughts on whether that should be the driver we rely on, or we should look at maintaining other driver just for the perf and scale stack?
So I suspect
I'd prefer to have one.
I was going to say the opposite. But go ahead, Kevin. You go first.
I was just going to say I'd prefer to have one because then it's a forcing function to actually get these things added into that example driver. I know in the past we haven't been as good at keeping up with putting the newest features that make it upstream into the example driver. Part of that was because there weren't as many people contributing it in the past. I kind of created the initial one, did the base work, and then stopped working on it. So a lot of it is probably my fault, but we've had in the last couple months more people coming in to actually contribute to it. So we have started adding new things back there. But I think if the performance tests and the scale tests required it, then as a prerequisite, then it would force us to actually add them there.
I think that's a valid argument. That's a good point. My concern is I want the example driver, and maybe this isn't where it is right now, but probably this is where it should go if it's not already there, to be like, the starting point for driver authors, or either we need two things, and maybe they can be served by one thing. We need at least two things. We need a sort of great starting point for driver authors to pick up and then just add their custom logic in. We also need that sort of adheres to all the best practices, and like we've talked about, like a feature gate discovery mechanism that we could build into it, right? Things like that. We need that set of work, and then we need something that we can use to exercise both our functional and scale tests. And I'm concerned that the incentives for the way you'd structure each of those might be different to make it quick and easy to add things for scale and functional tests versus to make it like really production quality, follow all best practices. So my concern is trying to address both of those with one thing, but that's something I guess I would look to those implementing it to comment on.
No, that's fair, because otherwise you get really complicated logic potentially in this driver that's supposed to be an example.
I think it's probably going to be okay. We have the overall setup that's the same no matter what we are simulating. And then we do have some custom logic, and we basically need to branch. We need to say the example driver runs in a mode where it is very simple, 1 GPU or 8 GPUs per node. We have another mode. We talked about that at KubeCon. We actually agreed that it would be okay to say it now simulates a certain vendor device, because the device is so well known and it takes advantage of certain new functionality like partitionable, that it just makes sense to be in the example driver as a stand-in for that functionality. I think that would fit into this alternative branch or subdirectory. It should probably be a different subdirectory even, where what it publishes in resource lists, which is ultimately what differs, and how it prepares resources, that this is all nicely encapsulated in different packages, and you just need to read one of them to understand what's best practice.
Yeah, that's a good point. You might be able to do it with one if you structure the code properly. We're running low on time. I wanted to give Laura a chance, but one quick thing is, have we thought about, LA, the testing of multiple drivers in the scale test, right? Like just one driver of one type of device, but we actually have code, right? That the whole point of it is to create constraints across multiple devices from different drivers. And I don't know that there's a particular scale issue if if all those devices are from the same driver versus different drivers. I doubt it. I don't see any, but it seems like something we should be able to, if we're pulling multiple resource slices from across different drivers and bringing them together, it might be a little bit different, the behavior.
Yeah, that's a good point. I'll note it down to take that, especially the one where we do some kind of alignment on attributes. I think that is a structured parameter feature, and we should have that tested for GA.
Yeah.
Yeah.
Thank you. Laura, with our 2 minutes left here.
Yeah, just that, like, the ETE node tests kind of have this thing too, where there's kind of like a dinky like test driver interface in there. This also for like, there's a hollow kubelet for ETE nodes. So like the idea that like different components have like different test variations is also happening on that side, including for DRA. So I do think there's some room here for us to kind of make more of at least like an overview between like you and me, maybe LA, or just generally about where all of these interfaces that represent a example, quote unquote, or test, quote unquote, driver is probably going to be valuable as we're all moving on them at the same time. And then it also sounds like the idea of testing multiple DRA drivers in the scale tests also has some overlap with what goals might be regarding conformance tests. And if there's something to borrow about like how conformance tests are usually harnessed for the purposes of scale tests that test many different drivers for you, LA, then I think that might be another good connection point to make sure that we're kind of following whatever the best practices in like documentation organization are regarding that to make that easy to keep track of long term. That's all.
Sure. I just have a quick question. So it looks like there are a lot of unformed opinions and more discussion need to have happen on this. Is there a need to sort of schedule a follow-up call specifically dedicated to this work, or should we all be focusing on the issue and writing thoughts there?
I think if you feel a follow-up call is useful, coordinate that on Slack, and we can create a Zoom for it if people want to make it public, or you can just that's probably the right thing to do.
Got it. Okay, thanks.
We have like a couple seconds left. Gaurav, if you've got a quick comment.
Sure, let me try. So I wanted to restart some discussions about standardizing the device attribute names. I think our current structured parameter SCEP calls this out as a GA graduation criteria. So I'm guessing we want this to go in before GA, right? So I wanted to understand, like, is someone working on it? And if not, maybe I can try moving this forward.
Sounds like you volunteered.
All right. So just one last question. Is it fine if we make updates to the structured parameter SCEP itself for this, or?
Yes. Yeah.
Okay. Yeah. Okay, cool. All right.
Yeah, you can submit PRs to that, and that's fine.
I wanted to raise a meta point related to this. This might be related to the downward API changes. I mean, it is not directly, as in the work is not directly related, but one could be the forcing function for other and stuff like that. So,
gotcha.
So downward API isn't on my. I don't think it's even anywhere on these planning charts, unless it's in like the stuff we've talked about that we haven't done. It's actually pretty hard to do. Patrick and I spent some time talking about it at KubeCon because of as is versus as was and other information. So if that's important, please, let's raise that on Slack.
Sure.
Okay, awesome. Thank you, everybody.